As if failed motherboard capacitors weren't bad enough, power supplies are the next frontier when it comes to repairing vintage computers. Let's check out a few new options for a couple Mac models that make things much easier. The Mac IIsi is notorious for power supply problems these days. In a previous video, I showed my attempts at fixing these, but as I found, it's not always possible. Capacitor leakage can damage circuit boards beyond repair, rendering the whole PSU useless. There's good news though. KMac Vintage has a surefire fix for these machines, and I was sent a couple to test out. These are pretty clever. They use a pair of commodity parts to replicate the function of the original PSU in conjunction with a custom circuit board. Putting it together is straightforward, and it starts with salvaging some parts from your dead power supply. First is the wiring harness that goes to the motherboard. You could just cut the wiring if you prefer, but I chose to desolder mine since they put these nice crimp ferrules on the ends. This thermistor isn't needed, so it can be left behind. Another thing to deal with is the AC input panel. The original PSU can power a monitor connected to the pass-through socket when the computer turns on, but the KMac board doesn't support that functionality. The easiest thing would be to simply cut the wiring going to the pass-through and leave it dead. And if you aren't comfortable working with mains voltage wiring, this is the safest approach. I decided to rewire this panel so the pass-through was in parallel with the input, so it would be on all the time. Next up was soldering the wiring harness to the PCB. This is really the only bit of soldering you have to do for the whole project, and it's easy as the connections are clearly labeled. An optional feature you can take advantage of is to solder the wires from a USB cable to these through holes, which can power a hard drive emulator like a Blue SCSI. There are two other parts you need to pick up to complete the assembly. One is an AC to DC module that outputs 12 volts, and the other is a mini ATX power supply to break out the other voltages the Mac needs. I simply cut the input wiring shorter on the ATX supply, screwed the leads into the output terminals on the DC converter, and plugged it into the PCB. The supply module then gets secured to the board using the included nylon standoffs and screws. Lastly, I connected the AC input board wiring to the appropriate terminals on the supply module, then stuffed it all back into the original enclosure. It's a bit of a snug fit, but no modifications to the case need to be done otherwise, and it looks completely stock once it's all buttoned up. I dropped it into my IIsi and pressed the power button, but nothing happened. All the voltages looked good, but soft power wasn't working. I tried a different ATX adapter, but got the same thing. Well, this is what beta testing is all about, so while I waited to hear back on what to try next, I got to work on another Mac model that also suffers from power supply problems. This is an LC3, though others in the same so-called pizza box form factor are equally affected. It's a similar story. Leaking electrolytic caps severely damage the circuit board in the PSU and keep it from working correctly, if at all. Of course, leaking caps on the motherboard could do the same thing, and since this machine was new to me, I had to take care of those too. So I pulled the whole computer apart to give it some TLC. The CPU on the motherboard caught my eye. It's a Motorola 68030, and the sticker on top said it's a 25 MHz part. I've heard of manufacturers sometimes downwriting components in order to fill shortages, so I expected it to say 33 MHz underneath. So imagine my surprise to find it's actually 16. I've read that 030s tend to handle overclocking pretty well, and it looks like Motorola shared the same opinion. I'm of the opinion that recapping clean PCBs is easier than on dirty ones, so I let the board soak in a tub of isopropyl alcohol while I tackled the power supply. These are more compact than the ones in the IIsi, which makes them easier in some ways and harder in others. With the housing apart, I could remove the PCB and desolder the wires from the AC input. And like with the IIsi, I'd need to salvage the wiring harness that goes to the motherboard, but also remove this plastic liner from the enclosure. KMAC's solution for these looks familiar. No more soldering is needed as the output connections use a terminal block, though I did tin the leads from the mini ATX power supply for simplicity. The 12-volt supply is a smaller model, but since the LC series has lower power demands, it's totally fine. I pulled the wiring harness conductors out of the plastic connector, and they have crimped ferrules on their ends too. I chose to apply some heat shrink tubing around them just to make sure they wouldn't accidentally make contact when screwed into the terminal block, and did the same for the AC input wires. If you cut the wiring and strip the ends instead, this step isn't necessary. Unlike with the IIsi, some modifications to the PSU enclosure are required. This tab is in the way of the new PCB, so it needs to be removed, which is as simple as bending it back and forth until it breaks off. The corresponding tab on the top cover has to go as well. Because this is a pretty cramped PSU, I played it safe and applied a layer of Kapton tape as insulation. Maybe the trickiest part of this whole thing is making sure the wiring harness is routed correctly in this cutout, and that this metal tab fits between the PCB and ATX adapter. Put the cover on and screw back in, and you're done. And along those lines, the LC's motherboard had finished drying, so I got its electrolytic caps replaced with tantalum ones. There was seemingly no damage from the leakage, so I caught it right in time. I took the opportunity to clean the rest of the system and get it reassembled, but wanted to do a couple of upgrades in the process. First was swapping the mechanical 80MB drive for a blue SCSI, since these old drives aren't exactly reliable anymore. And second was filling the lonely RAM slot with a SIM to bump the LC3 up from its stock 4MB. Does it work? Of course. The KMAC power supply gives this machine a new lease on life, and cleaning and recapping the motherboard was sorely needed. But what about the IIsi's PSU? I gave it to a friend to take to the VCF Midwest Vintage Computing Convention where KMAC had a table. After some diagnosis, it turns out it simply needed a different model of transistor for the soft power circuit. Apparently, IIsi's can be picky about this. I dropped it into the Mac and got the machine put back together. Yep, of course it works now. And what's especially nice about both of these solutions is their price. The PCBs from KMAC are about $15 each, with the 12-volt PSU going for around $12, and these ATX modules running between $20 and $30. So for less than $60 total, and with only a little soldering, you can take all the hassle and guesswork out of fixing an original power supply and just jump straight to one that works. Of course, some people prefer original designs or just doing things the hard way, and for them, there's another option I've been working on in collaboration with electronics expert Kai Robinson. It's a set of reproduction IIsi PSU circuit boards, and while we're still working the bugs out of them, they're showing a lot of promise. You'll need to be willing to spend the time transplanting a lot of components from an original PSU, but I'll hopefully have more news about this project in the future. But at least for now, the KMAC options are your best bet. If you have a IIsi or LC series machine you're struggling with or gave up on, or just want some preventative maintenance for a working one, it's hard to argue with simple and cost-effective solutions like these. Thanks again to KMAC Vintage for sending these boards my way. I'll include links to everything in the description below. If you liked the video, I'd appreciate a thumbs up and be sure to subscribe. Here's another video you should check out, and as always, thanks for watching.